Welcome back, everybody. Today, we're going to be taking a deep dive into something pretty interesting. It's called scientific bubbles. We're going to be looking at a new study from Nature Human Behavior that looks at how scientific knowledge can get trapped in a bubble.
Okay.
Especially in biomedicine.
Right.
And we're going to kick things off with a story you might even remember.
Okay.
Dr. Piero Anversa and his groundbreaking work on cardiac stem cells.
Yeah, his research really captivated the scientific community for a while there.
Exactly.
It suggested that damaged heart tissue could regenerate using stem cells, so naturally it attracted a lot of attention and funding.
It felt like a miracle cure was right around the corner, but there was a catch.
Yeah.
Other scientists tried to replicate his findings and they just couldn't.
Right.
What seemed revolutionary ended up being not so revolutionary.
It's a classic example of what we call a scientific bubble, where hype and initial excitement around a finding overshadowed the need for rigorous verification and diverse perspectives.
So it's like that saying, if it sounds too good to be true, it probably is.
Yeah.
But how do we know if research is truly groundbreaking or just caught in a bubble?
That's a great question.
That's where this new study comes in, and the idea of a diffusion index.
Yeah, precisely. Think of it this way. Imagine a study comes out and it only gets cited by the same small group of researchers.
Okay.
Maybe even from the same institutions. That's low diffusion. It's like an echo chamber effect, limiting critical evaluation.
Okay. So it's like a closed circle where everyone's agreeing with each other and they're missing flaws potentially in the research.
Exactly. Now contrast that with a study that sparks interest across various fields. So scientists from different backgrounds start incorporating the findings into their own research, generating new insights and applications. That's high diffusion, and it suggests the findings are robust and have broader implications.
So Dr. Anversa's work would have had low diffusion, while something like cancer immunotherapy research, which has had a much broader impact and continues to grow, would show much higher diffusion.
You nailed it. And the researchers didn't stop there. They looked at a massive data set of over 28,000 biomedical subfields to see if this pattern held true on a larger scale.
And did they find a link between this diffusion index and these scientific bubbles bursting?
What they discovered was actually quite remarkable. Low diffusion consistently predicted dramatic drops in attention across diverse research areas. It didn't matter what the research was about. If it was stuck in a bubble, it was more likely to face a reckoning.
Wow, so this diffusion index is almost like a warning sign.
Yeah.
But what makes some research stay trapped in a bubble while others spread like wildfire?
That's where things get even more intriguing. They discovered that limited social diffusion was an even stronger predictor of these collapses than limited scientific diffusion.
Hold on, what's the difference? You're losing me a little bit here.
Okay, let me clarify. Scientific diffusion is about how research spreads across different research topics.
Okay.
Social diffusion, on the other hand, tracks how it spreads across different groups of researchers. So a study might get cited in diverse fields, but still only be picked up by scientists who are already closely connected to each other.
So it's not just about the research topic itself, but also about the people involved and how diverse their perspectives are.
Exactly. Diverse perspectives are crucial for robust science. When research only circulates within a small, homogeneous group, it becomes more susceptible to biases and blind spots. They might be missing critical challenges or alternative interpretations.
That makes a lot of sense. It's like having a diverse team working on a project. They bring different experiences and ideas to the table, leading to a better outcome.
That's a great analogy, and this leads to some pretty important questions. If we can identify these bubbles early on, what can we do to prevent them?
Right. Knowing that low diffusion is a red flag, what can we do to ensure research is robust and reliable?
Well, there are several potential solutions that this study highlights. These range from changes in how funding decisions are made to the role of scientific journals and even the information platforms researchers use daily.
This is getting really interesting. I can't wait to dive into those potential solutions.
Yeah.
But first, we need a little break. We'll be back shortly to explore how we can all play a part in building a more trustworthy scientific ecosystem. Stay tuned.
So let's get into those potential solutions. One of the most impactful areas is how research gets funded. Imagine if funding agencies, those who decide which projects get money, started looking at this diffusion index.
It makes sense. Instead of just counting citations, which we now know can be misleading,
Right.
They could consider how widely research spreads and who is engaging with it.
Precisely. Funding agencies could prioritize projects showing high diffusion, indicating the research is gaining traction within a diverse scientific community. This could help ensure that valuable resources are directed towards research with real potential.
It's almost like a venture capitalist evaluating a startup. They don't just look at immediate profits, but consider the company's long-term growth potential and diverse market reach.
Yeah, that's a great analogy. Now let's shift gears and think about the role of scientific journals. Imagine if they, too, started considering diffusion when deciding what to publish.
So instead of chasing after the hottest topics that might just be a flash in the pan, they could prioritize research that's gaining traction across different fields and sparking diverse conversations.
Exactly. Journals could play a significant role in curbing the spread of research stuck in a bubble and elevate work that shows promise for long-term impact. This would also encourage researchers to focus on producing high-quality, impactful work that resonates with a broader scientific audience.
That would be a real shift in the scientific publishing landscape. But let's bring it down to a more personal level. What can individual researchers do to ensure their work contributes to robust science and avoids falling into a bubble?
It all starts with collaboration. Actively seek out researchers from different backgrounds, institutions, and even disciplines. By engaging with diverse perspectives, you can challenge your own assumptions, test your findings in new contexts, and contribute to a more reliable body of knowledge.
It's like that saying, two heads are better than one, but on a much grander scale. Plus, collaborating with others opens up opportunities to learn new things and expand your own research horizons. It can be an incredibly enriching experience.
Absolutely. And another powerful tool for researchers is transparency. Clearly communicate your findings, methods, and data to a wider audience.
You mean like making research more accessible to those outside of academia? I love that idea. Science shouldn't be confined to ivory towers. It should be shared and discussed openly.
Precisely. Engaging with the public helps ensure your work reaches a broader audience, increasing its impact and contributing to a more informed society.
So we've talked about funding agencies, journals, and individual researchers. Are there any other areas where we can make a difference?
Think about the information platforms that scientists use every day, like PubMed. Imagine if these platforms incorporated the diffusion index into their systems.
That would be amazing. Researchers could see at a glance how widely a study has spread and whether it's been picked up by diverse groups. It would be like having a built-in bubble detector.
Exactly. This would encourage researchers to look beyond just citation counts and consider the diffusion patterns when evaluating research.
So it sounds like we need to move beyond simple metrics and embrace a more holistic view of how scientific knowledge is generated and shared.
You got it.
Yeah.
It's about fostering a scientific culture that values diverse perspectives, rigorous evaluation, and open communication. We need to create a system where robust science thrives and bubbles are less likely to form in the first place.
This has been incredibly insightful. It feels like we've uncovered a hidden layer of the scientific process that many of us weren't even aware of.
It's definitely an important conversation to have. And as we wrap up our deep dive, there's one key question we want to leave you with, dear listener.
If limited diffusion really is a sign of potential scientific bubbles, could promoting more diverse research collaborations be a key to preventing them?
That's a question that deserves serious consideration. It's a call to action for everyone involved in the scientific process. What role can you play in supporting robust, reliable science?
That's a great point. It's not just about scientists working in labs, it's about all of us. Whether you're a researcher, a funder, a journal editor, or simply someone curious about the world, you have a role to play.
Absolutely. You can start by being more aware of these dynamics. When you encounter research, ask yourself, who conducted this research? Who is citing it? How broadly has it spread? Are there diverse perspectives represented?
It's almost like being a scientific detective, looking for clues to assess the strength of the evidence.
And remember, science is a dynamic process. There will always be new discoveries, new challenges, and yes, even new bubbles. But by embracing critical thinking, encouraging open communication, and championing diverse perspectives, we can work together to build a more reliable and trustworthy foundation for scientific knowledge.
And that's a wrap on our deep dive into scientific bubbles. We hope you found this exploration insightful and, dare I say, even a little bit exciting. After all, understanding how science really works empowers us to make better decisions about the information we encounter every day.
It's about fostering a sense of scientific literacy in all of us.
Exactly. So stay curious. Keep asking those critical questions and join us next time as we take another deep dive into a fascinating topic.